This is Bob Capetta from the College of the Florida Keys, and this lesson is on point plotting. So let's give ourselves some basic definitions first. We have a coordinate plane. This is the x-axis in the horizontal direction, and this is the y-axis in the vertical direction. This is x-axis positive side to the right, x-axis negative side to the left, y-axis positive side up, y-axis negative side down. And our interest is in plotting points. So if I have a point 1, 2, that means I have to go positive 1 in the x direction, positive 2 in the y direction. 1 in the x direction, 2 in the y direction. 1 block east, 2 blocks north. And this gives us the point 1, 2. If I want to go ahead and graph the point 3, -4, that's positive 3 in the x direction, down 4, -4 in the y direction. So what will that look like? 3 in the x direction, 1, 2, 3, 3 east, 4 south, 1, 2, 3, 4. So approximately here would be 3, -4. If I'm interested in the point -3, +1, that's -3 in the x direction. So x direction is left and right. -3 means to the left. 1, 2, 3. So go 3 blocks west, 1 in the positive y direction, 1 here will give me -3, 1. And let's do one more. Let's do -2, -3. So that is -2 in the x direction. So negative x is to the left. -3 in the y direction, that will be 3 units down. 3 in the negative y direction. So 2 over from the starting point from 0, 0, 2 left, and 3 down, 1, 2, 3. And I'm about here for -2, -3. Now you'll notice something. My XY plane separates into 4 regions. This region where the x value and the y value are positive, to the right and up. Everything up here is called quadrant 1. So in that situation, x and y are both positive. We're in the upper right-hand corner. If x is negative and y is positive, sort of like -3, 1, this entire corner, this entire fourth, is quadrant 2. This corner, where x and y are both negative, to the left and down, is quadrant 3. And if x is positive and y is negative, so that's over to the right but down, that's quadrant 4. So the quadrants are defined by the signs, whether it's positive, positive, quadrant 1, negative, positive, quadrant 2, negative, negative, quadrant 3, positive, negative, quadrant 4. That's what we're looking at. Now, eventually, our goal is going to be determining solutions to linear equations. So, for example, if I'm looking at 2x + y = 5, I want to know which points make this true. So we'll look at 2x + y = 5. And the first question I will ask is 0, 5 a solution? So let's see, where is 0, 5 if we plot 0, 5. 0 on x, remember here's the x direction, here's the y direction. 0 in the x direction, 5 in the y direction, 1, 2, 3, 4, 5. So this is the point 0, 5. Is 0, 5 a solution to this question? Well, let's take a look. I'm going to plug in to see if it's true. We're starting with 2x plus y equals 5. We'll plug 0 in for x. X is 0. 2 times 0 plus plug 5 in for y. Does that equal 5? Does 0 plus 5 equal 5? The answer to that is yes. So 0, 5 is a solution. How about 1, 3? Is 1, 3 a solution? So again, I'm going to plug 1, 3 into 2x plus y equals 5. So 2x plus y equals 5. 1 in for x. Does 2 times 1 plus 3 equal 5? Does 2 plus 3 equals 5? Again, that's yes. So 1, 3, 1 on x, 1, 2, 3 on y, 0 on x, 5 on y. Those would be 2 points that we have. How about 2, 4? Is 2, 4 a solution? So we go with our equation, 2x plus y equals 5. Plug 2 in for x, 4 in for y. Does 2 times 2 plus 4 equal 5? Does 4 plus 4 equals 5? And that's no. What we're interested in is what are all of the solutions to 2x plus y equals 5? Is there a way for me to find all of them, or is there a way for me to graph them? So let's go through our process. If our goal was to graph 2x plus y equals 5, what will that look like? So we're going to try to find some points. We have some already, but let's go through the process. 2x plus y equals 5. I'm going to go ahead and solve for y. I'm going to subtract 2x from both sides and say y is 5 minus 2x, or negative 2x plus 5. Then I'm going to choose various values for x and see what is the corresponding value for y. If x is 0, y is negative 2 times 0 plus 5, which is 0 plus 5, which is 5. If x is 1, y is negative 2 times 1 plus 5, negative 2 plus 5, which is 3. If x is 2, y is negative 2 times 2 plus 5, which is negative 4 plus 5, which is 1. If x is 3, y is negative 2 times 3 plus 5, which is negative 6 plus 5, which is negative 1. Let's maybe go to x is negative 1. Negative 2 times negative 1 plus 5, which is 2 plus 5, which is 7. So what are all the points that I have? Putting all these together, I have a collection of points here. X, y. We have x is 0, y is 5, x is 1, y is 3, x is 2, y is 1, x is 3, y is negative 1, x is negative 1, y is 7. So I'd like to graph those points to see what that looks like, to get our idea of this. So let's do that. So we've got some points here. We had 0, 5. So let's see where that is. X value is 0, y value is 5, puts me there. So we'll go ahead and put that one in. The next one we had is 1, 3. X is 1, y is 3, puts me here. Next we have 2, 1, x is 2, y is 1, all in first quadrant. Then we have 3, negative 1. And finally, I have negative 1, 7, which I guess we can see. That'll be, first of all, 3 negative 1s in quadrant 4. Negative 1, 7. is up here in quadrant 2. So it certainly appears as if all of these points lie on a straight line. So if I were actually to graph this line, you'll see it will indeed go through those points. Our line was 2x plus y equals 5. And you'll see it goes through all of those points. So when we're given an equation of a line, our goal is to determine which points are on that line and then to graph them accordingly. So that's something we're going to look at as we're going through this process. All right, so let's take a look at another equation. If I am dealing with y equals negative 2x, what will that look like? What will those values be? So if I have y equals negative 2x, get this in a good spot. We'll pick values for x and find corresponding values for y. So here's x, there's y. If x is 0, y is negative 2 times 0, which is 0. If x is 1, y is negative 2 times 1, which would be negative 2. If x is 2, y is negative 2 times 2, which is negative 4. If x is 3, y is negative 2 times 3, which is negative 6. If x is negative 1, y is negative 2 times negative 1, which is positive 2. Which gives me a collection of points, 0, 0, 1, negative 2, 2, negative 4, 3, negative 6, negative 1, positive 2. So I'd like to graph those and see what that looks like when we put all those together. So I will do that. And we'll get rid of all of these from before. And we'll graph the new points and the new line to see what that looks like. So the first point I have is 0, 0. Which you can see that's right in the center. X value is 0, y value is 0. Next one I have is 1, negative 2. One on x, so 1 block east, 2 blocks south for negative 2. Next up we have 2, negative 4. 2 over 4 down. Next up we have 3, negative 6. So 3 over 6 down. And finally I have negative 1, 2. So to the left 1, up 2. So there's all of my points. Again, they appear to lie on a straight line. The points down here are in quadrant 4, 1, 2, 3, 4. These 3 points are in quadrant 4. X is positive, y is negative. This point up here is in quadrant 2. If I want to graph the line is y equals negative 2x. And you'll see it goes through all of those points. And we've successfully constructed that line. Okay, let's go ahead and do one more like that with our point plotting strategy. This time I'm going to go with y equals negative 1/2 x plus 6. And let's talk about a strategy to do this. Y equals negative 1/2 x plus 6. And we just want to play the point plotting game here on this version. And the fact that I have a 2 here tells me that I should use multiples of 2 for my x values so that the fraction goes away. So let me show you what I mean by that. So here's x. Here's y. 0 is a multiple of 2. Negative 1/2 times 0 plus 6 is 0 plus 6, which is 6. I don't want to use an x of 1 because negative 1/2 of 1 is negative 1/2. Plus 6 would be 5.5. It'll just be a little more difficult to graph. So I stick with multiples of 2, multiples of the denominator. Negative 1/2 times 2 plus 6. 1/2 of 2 negative 1 plus 6 is 5. The next multiple of 2 I'm going to use is 4. So negative 1/2 times 4 plus 6. A half of 4 is 2. So that's negative 2 plus 6, which should be positive 4. Let's go to 6. Negative 1/2 of 6 plus 6. A half of 6 is 3, so negative 3 plus 6 is 3. And let's pick a negative number, and I will pick negative 2 because I want it to be a multiple of 2 to make it easier for me to graph. Negative 1/2 times negative 2 plus 6. Negative times a negative is a positive. A half times 2 is 1, plus 6 is 7. So I have all of these points that I can use. I have 0, 6, 2, 5, 4, 4, 6, 3, and negative 2, 7. So those are the points I'm going to want to graph on my grapher to see what they look like. So let's move this aside, and let's eliminate all of these that I just did. And we'll put the new points on there. So starting with the point 0, 6. So you'll notice 0 over 6 up. Next one is 2, 5, 2 over 5 up. Next up is 4, 4. So 4 over 4 up. Next up is 6, 3. So 6 over 3 up, and you can see they all look like they're lying on a straight line. These are all in quadrant 1. Then I have negative 2, 7. Which is in quadrant 2. And I want to graph this, so it was negative 1/2 x plus 6. So y equals negative 1/2 x plus 6. And you'll see that that line goes through all those points, and it extends, so I could move this around and show you that the line extends that way. The line extends up that way. And that will conclude this lesson.